escuchas? Entonces, all right. All right, sorry for these technical problems. We're figuring out how to connect Omar's sound. There is a small there is a small echo because I'm monitoring sound. Please wait for a sec while Omar reconnects. Omar, can you try and speak, please? Omar?
Hello, can you hear me? Can you hear me now?
Ah, now I can hear you. Let me check if we can hear you on
Yes,
on Twitch.
perfect, perfect. Just
All right, people can hear you now on Twitch, so let's go. Omar, can you hear us? Can you hear me? We can't hear you anymore now.
Hey, can you hear me? Trying here. Can you hear me? Nope.
right now, drawing audio. Can you hear me? Yes. Okay. Thank you. Thank you. Now, second trial. Can you hear me now? Can you hear me now? Okay. Perfect. Okay. I don't know what's happening. Sorry. Again. So, what we're gonna be doing today is coding an ERC721. This one will be based on the StarkNet EDU workshop. Automated workshop is a very good workshop where you can learn a lot about how to deploy your own RC721s. I will send you the link a little bit later. Then we're gonna unit test it using Protostar. Protostar is a very nice tool for you to be able to test your contracts, also deploy them. But in this case, we're gonna be focus on the testing parts. So we'll be able to test it using Cairo itself. So we don't have to depend that much in Python. We will have to depend a little bit, but not that much as with only Python test, which I think is a good practice, and it's also inspiring Foundry. So we'll be exploring that. And then we're going to be giving a couple of cheat codes and testing tips that will be useful for you. So I believe this is a very important workshop because we often talk about these sanity steps. I don't know if people call it that way. That's the way I call them. But I also want to apologize because my camera is not working right now. Sorry for that. In a next workshop, you will be able to look at me. So the sanity steps are unit test first, then devnet or local, then testnet, and finally mainnets. So we always try to start with the unit test. And in Protostar, we'll be able to do them and also deploy them locally. So we'll be doing the first and second step using Protostar locally in a local Protostar network, and a local Protostar cheat network. And that's how we're going to be calling it today, a cheat network of StarkNet. And also we'll be able to deploy them to the testnet. And of course, the mainnet bots will be staying at the local level and also deploying the testnet just as an example. So this is a small meme. Please, I also clarify that this is a meme. It's very important for you to test your contracts. And the nice part is that using Cairo, you will be able to use them with the same Cairo code that you're already using for your smart contracts. So Protostar is, sorry for the starting part there, but Protostar is like you can think about it as a combination between Truffle and Foundry for Ethereum. So it has best practices from Truffle and from Foundry. We'll be looking at them. From Foundry, we will be taking the testing part, something that Foundry is very famous for. And from Truffle, we'll be taking the migrations parts, which are very relevant too. So today we're going to be focusing on unit testing because the migrations are not yet fully developed. They are in the workings by the Protostar team, but soon you will be able to use them and they will be very, very useful when that time comes. So first, calling an ERC 721. So today the focus is not on this part, it's more on the testing part. But for that, I recommend you that you get the first QR code here in order for you to access the ERC 721 automated workshop. Is the first QR code. There you will be able to follow some steps and enjoy making an ERC 721 where you will be able to breed animals. It is very nice and very well done workshop. And also, if you need help, you can check David's Barreto's tutorial, StarkNet Developer Advocate. This is the second QR code. This guide by David is very useful, very good. So I don't think that there's a necessity today to go deep into how to code this ERC 721 or how to finish these workshops, but focus more on the testing part. Okay, so if we go right now to the codes, let me stop sharing a bit and share again my screen and go to the codes so we can review what we'll be doing today. Okay. Okay, let's go and share it screen. Sorry for that. And we have these codes. I will send you also, I will add the QR code here for the repo where you will find this exercise. But for now, let's go. Don't care for the red parts. I don't know what is happening right now to the Visual Studio Code widget that is not identifying that there's not an error, but it's okay. Don't care about that part. So if we go let me share first my terminal. Just to confirm with you guys, are you able to look at the terminal right now? Because I don't know if you're able right now to see only the terminal. Okay, let me go for it. I think so. I think you're able to see the terminal. Okay, so here we're on our code, and if we create a new Protostar repository using Protostar init, it will automatically build you a nice couple of directories that you will be able to use. These are good practices. For example, here, if we can explore how our code is built, how our directory is built, yeah, we'll be able to see that Protostar automatically created for us a build directory. There we have our JSONs with the compile files. In this case, we have two different contracts that were compiled, an ERC721 custom and ERC721 original. Then in the lib directory, we'll be able to see everything that we install. So for example, we're installing here the Cairo contracts from OpenZeppelin. And this is all the code inside it. Also, it will create you a CRC folder automatically. You can change the name of it. Maybe you prefer to call it contracts. I don't know. But inside CRC, I create two traditional directories. These are mine. One is called contracts, one called interfaces, and one called Python. And finally, it will create you a test directory. There we'll be able to see all the tests that we are coding. Also, of course, we will have a configuration file called protostar.toml. Inside of it, we'll be able to see the configuration of our Protostar. Right now, we have a very simple configuration, and the two most important parts are these ones. In Protostar contracts, we are telling Protostar what are the contracts, what are the paths for the contracts that we're going to be compiling and then deploying. In this case, we're telling him search for lib Cairo contracts. So enter the Open Zeppelin directory that we just installed, and then we'll be using this ERC721 mintable vulnerable.cairo. We will call this contract ERC721 original. Also, we'll have a second contract called ERC721 custom, and this is the path for it. Okay, so when we compile our contract, the Protostar automatically will gather these files from these paths and then create our JSON files that we'll be able to deploy. Second, we have this Protostar share command configs. In here, we're specifying there's another path, a Cairo path, where it will be able to find the Cairo contracts. We'll be able to find the Cairo contracts imported from Open Zeppelin. Okay, having said that, let's go back to the command line. And here we can start by typing Protostar Protostar builds. And right now we are compiling our contracts. We are compiling the two contracts that we indicated Protostar that we'll be using today. Okay, so it compiled them and it stored them inside the build directory. Here we have our two ERC721 custom and ERC721 original compile. Okay, the next step for us will be to deploy it. It's also very easy to deploy using either the DevNet, the Shard Labs testnet, DevNet, or the testnet or the mainnet. So in this case, we'll be deploying straight to the testnets. Very easy again. We can use Protostar deploy. Then we can indicate that the contracts in order to deploy will be sorry, this is not required right now. It was a Protostar deploy, and let's go and deploy the ERC721 custom dots. Let me get out of the build. Right now I'm on the build directory. Let me get out of it, and we can go and deploy. Protostar deploy, and then we indicate what is the contract that we want to deploy. Here is the custom one. Let's go directly to the custom one. And also we can indicate the network. Here we indicate testnets. And here we're gonna be adding our inputs. Now, if we go, before deploying this, let's go to the constructor and see what are the inputs that the constructor is asking for us. So this code is inside CRC, and then if we go to contracts, we'll find this one. This is the contract that we'll be deploying today. If we go to the constructor to see the inputs that the contract is asking for us, we'll see that it's asking for 3 different arguments: name, symbol, and owner. Now, I don't know if to call it a problem, but the intention here is that name should be in felt format, symbol should be in felt format, and the owner, which is originally a hex, it also have to be in a felt format. So we have to convert strings to felt and also a hex to felt. Okay. So for this, there's always a small script that everybody uses. It's on almost every relevant repository using Cairo, and it's called utils.py. And I don't know who created it. I have seen it in a lot of repos, but I don't know what the origin is. But in here we have several very useful functions that we can use to get to convert into different values. For example, we can convert right now the hex to felt. So for example, I can have my address of my StarkNet account in a hex format and then convert it into a felt. Also, we can convert the string to a felt, which is what we need for the name and the symbol of the token. So we can use them really easily using the terminal. Let's create a new terminal account here. So let's go down here and let's go. Let me get out here. Let's go back to our previous repo, StarkNet Workshop. In here, let's go to StarkNet. Perfect. And if we go using Python 3, and then go into CRC Python, you will be able to access the Python code. Very simple. So right now we can use, for example, let's think that we want to convert a string to a felt. For example, new token, and it will provide us with. Sorry, I clicked on felt array. It should be only felt, and it will provide us with the felt that we need to input, as in this case, for example, the name of the token. We can do the same with, I don't know, like this. The symbol could be ta ta ta, and that will be the felt value for it. Also for the hex, we can use this one, and we can add, you know, as a value. But in this case, this is not an actual. Sorry, it's hex to felt. Here I got it wrong. But of course, this is not a felt that I'm adding. But suppose it's a felt. Sorry, suppose it's a hex. And here right now it's an error because it's not an actual hex. But if we have, for example, an address, we can convert it into felt, and that's what we need right now. So I will be providing here my address, my StarkNet address, and convert it into a felt, so we can tell the contract that I am the owner of this contract and I can interact with it. Now we can exit Python. We exit and we're again back into our testing framework. So coming back to the deployment part, we're telling it, let's deploy this contract, ERC721 custom. We will do it to the testnet, network testnet, and the inputs will be, and if we go back to the code, we see that the code is asking for the name, symbol, and owner in that order. So I have them already converted and stored here locally. The name will be, sorry for this because it's going to be looking really awful, but that is the name. Then we have the symbol. And finally, we're going to be having the owner, which was originally hex. Right now it's an address. Okay, so we wait a little bit, and this should be able to deploy it to the testnets, and we'll be able to interact with it. So right now, as you can see, it was successful. It provides us with a contract address and also a Voyager address. We click into the Voyager address, we'll be able to access directly to it. Of course, and this is why we are focusing today on the testing part. But of course, it's not currently working on the testnet. We have to wait, I don't know, maybe 3 to 5 minutes for it to be live here, and we can interact with it. And well, as you can see right now, this is precisely the problem that we have with the testnet. That it's it takes a little bit of time for us to interact with it. So we have that small problem. So now let's go back and see what can we do about it, because we don't want to stay like this. This is not the ideal way to interact with this. We want to be able to quickly test and quickly iterate in our code. Okay. So while we wait for this to be able to be available for us, let's go back into our slides and go into the testing part. This QR code that you see here will take you to the repository with the code that I'm showing right now so you can access it, you can edit it, you can use it whatever you want, but it will be very useful because, at least for me, it's very useful to see another repos that shows best practices and a nice code that will allow me to apply it on my own smart contract. So feel free to look at it and give it a start if you want, and clone it and use it however you want. Okay, so let's go to the cheat codes parts by Protostar. They are, of course, inspired by Foundry. I don't know. I haven't found a single place where they explain the cheat code's name, why it's called cheat code. And at the beginning, it's not that intuitive because I don't know. It remembers to me when I was playing Grand Theft Auto 4, for example, and you have these cheat codes, where you add certain code and you have extra life or I don't know more powerful weapons. But I don't know. It sounded a little bit weird to me, but uh, after looking at it and exploring it inside Foundry and then with Protostar, you discover that is actually meaning that you are fooling, you're cheating the state of the blockchain. So you are like cheating in the sense that I will simulate or cheat that I am deploying a contract and that I am the owner. I am cheating that I'm making this call, so it's a mock call, but I'm actually not doing it. Okay, so you are constantly cheating, and for this you have codes, particular codes that in this case the Protostar team did. By the way, Protostar is open source, so you can also contribute to it. But yes, that is the name of the cheat code. It's I don't know if this is the best name, but you are cheating the state of the blockchain. So what are some of the most important cheat codes? And we will look at them directly at the codes, but I want to explain them before this way. So first we will simulate cheats at deployment. For that, we'll be using declare, prepare, and deploy codes. And it's important to tell you that all this code is inside hints. So the codes of the cheat codes are practically hints always, and you will have to code them easily using Python. But don't worry that if you don't know Python, it's a very simple. They are very simple to use. No problem. You don't have to be an expert in Python. Definitely, you don't have to have a high level of Python as, for example, when you need to test only using Python. This is much more easier in terms of the Python part, mainly where we'll be using Cairo codes. So when you want to cheat the deployment, you can use these two functions. Previously, and actually currently, you have another that is called deploy underscore contract call, but it will be not working no more in I don't know, like in the next deployment or Protostar, something like that. So we'll be focusing on what is the future and what stays current inside Protostar. So with the declare function, we will be able, as you can see in the green part of the code, we'll be able to set that this is the path to the contract that we want to deploy. Then we'll be use this declare contract to input as an input for the prepare function, and the prepare function has the particular part that will be able to add what are our inputs. So these are the inputs: name, symbol, owner. You can see it because we just did it in the testnet. So we have name, symbol, and owner, and there will be inputting these arguments that will go into the constructor. Okay, so these are the constructor arguments. And finally, using deploy, we'll be able to deploy the prepared contract, and particularly of relevance is for us to get the contract address, and we'll be storing it using the context. I will explain it a little bit later that, but we'll be using context dot erc721 underscore custom underscore address, and there will be storing the address. Okay, so we'll be looking at that directly into the code. But before, let us see another important part of the cheat codes. This is a cheat to deploy at the beginning of our contract, so we don't have to be deploying at each different test. So we can deploy at the beginning, and then we can interact with this deploy contract with the following test without the need to be deploying for each test. Okay, so this will make our test faster and a little bit cleaner for us to read. So at the beginning, we can deploy using we can deploy using the underscore setup underscore, and inside that code I am adding the previous declare prepare deploy code. As you can see, the code that I showed you before here, the declare prepare deploy goes actually inside this setup. So this means that we are setting up, we're using a hook, the setup hook, in order for us to deploy at the beginning of the contract and not requiring it to be deploying each time. Okay, so let's go to the codes and see this live. So here we have our test of the custom Cairo. Now, a small disclaimer, this code is optimized for learning purposes and could have a couple of not best practices regarding the format of the smart contract. It's mainly focused on showing the best practices regarding the test. Okay, so in here, if we go to the setup, you can see what I was telling you before. Here we are declaring, preparing, and deploying our contracts inside the external parts. And then we will have a couple tests. I will explain them in a moment. But these tests no longer require for us to deploy the contracts. And here, and this is the most important part, we're storing the contract address. As you can see, this is Cairo code, and we're using hints for the test. Hints inside, of course, our Cairo contract. So in here, as you can see, we're storing the contract address inside this context.erc721 underscore custom underscore address. This context part will allow us to use this variable. Anything that we store inside the context, then we'll be able to use it in other parts of our contract. So in the setup hook, we can do anything that is required to initialize the test. And then we can pass all this information throughout our different tests inside this test suite. So for example, let's go to the first test. We are simply testing the deployment of our contract. And inside here, and I will explain it a little bit deeper, but right now I want you to see this part where we're using a hint. In this hint, we're retrieving the address of our contract from the context variable, okay? And we're storing it inside a local variable called a temp variable called ERC721 underscore custom underscore address, okay? This will be helpful for us to later use this address when we are deploying and when we're using functions from the deploy contract, okay? So before going into that, let's go again to our browser. Let's go to our presentation. Oh, I cannot go right now. Well, no problem. Okay, so if we go right now and explore let me try to go to the Brave parts. This sharing screen stuff is a little bit confusing. Okay, let us go back to, I will stop sharing for a moment. I can see it right now. Share again. And okay. So if we go again to our contracts, we'll see that it's already deployed. Should be working right now. So you're looking right now at my testnets. And as you can see, the contract that we deploy using Protostar is now working. And we can explore it, of course. This is maybe what you're most used to. And in here, you can, of course, read the contract and write to the contract. And of particular interest right now for the test we're looking at is the name part. So if I go to the name, and then we can retrieve it in text format, query for it, and we'll be getting that this token is called new Qt token. And if you go to the symbol, we'll be able to see that the symbol is NCT. This is just a small example. And of course, if we go to the owner part, we'll be able to see who the owner of this contract is using the hex format. We can retrieve that the owner is this address. It's ending with A510. I can go right now to my starting account. Right now I'm using Argent, and we can see it also ends in 8510. Okay, so I am the owner of this contract. It was well deployed, so no problem in here. We can interact with it. We can write to the storage, no problem. We can read from storage. Okay, looks very, very nice. So explain a little bit more about what this custom ERC721 is doing, if in case you haven't done before the workshop, the automated workshop. This is simply a contract that allows you to mint an ERC721, and that's an NFT, for informally called an NFT. And this you can mint it, and you can provide it with some interesting properties. In this case, animal characteristics. These animal characteristics are legs, wings, and sex. So for example, let's go and mint one of these animals. For this, we'll not be using the traditional minting function. We'll be using the declare animal. So for example, I will provide it with a sex 1, legs 1, and wings 1. Then we click on transact. I will approve the transaction using my StarkNet account. And okay, so now we have to wait for it to pass. As you can see above, Argen is telling me that there's a current transaction in place. So we will have to wait for it. Pending transactions, declare animal. Again, this is not ideal, and that's why we're using the unit testing part and deploying locally, okay? So if we wait for this, we'll be able to have an animal. This animal will have one sex 1, legs 1, and wings 1, and we'll be able to retrieve this information using the getter function called get animal characteristics. That's practically all. That's what we're doing with this contract. It's a very simple contract. Again, we are now waiting for it. So if we go back to our test, now we'll be able to test these custom parts of our contract. Here, first we're starting with the constants. So we have an owner. This should be an address. Think of it like a hex address, but it doesn't matter because it's a test. So it's a false address. We have a name and we have a symbol. Sex, legs, and wings. Okay, just to a couple examples how we can test our contract. As we showed before, here we had setup, we're deploying there. And also we have a small interface that we'll be using a little bit down here, but this is a small interface, just as an example. Sorry. So in this first part, we'll be testing the ERC721 deployment part, okay? So we already know that we deploy it again up when we use the setup hook. Right now, let's see if the name and the symbol and the owner are actually the ones that we declare to be, okay? So again, we're retrieving from here the custom address and storing in this temporal variable called ERC721 underscore custom underscore address. Then we're calling the IER721 custom interface. For that, I have to import it above. Here I import from the interface part. This is an interface that I created. This is the interface you're looking right now. And in this interface, I declare some of the functions that we want to test right now. For example, we want to test the function called name, the one that we use right now, that we used previously in the testnet. You remember it, name, and it provides us with the name of the animal. Also the symbol function that we use above, or the owner function that we also use in the testnet. And then we will also testing this declare animal function that we also use. Let's go back to our browser and see if the function has already passed. No, it hasn't passed yet. No problem. So we have the declare animal function and we'll be testing it. Also, we'll be testing the get animal characteristic part and the get last token ID. I will explain a little more about them in a moment. The important part here is that we have an interface will allow us to interact with the actual code of the contract, that in this case is the ERC721 underscore custom underscore custom dot Cairo. This one, sorry, ERC721 custom Cairo. This is the actual contract, and we'll be using the interface as a way to interact with it in a more simple way. So again, let's go back here, and we're calling the interface and then using the name function from the interface. You saw before that we have this as a function we want to test, okay? So then we're adding a single argument that is called contract address. This contract address argument is the address that we retrieved before from the deploy contract, okay? So we're using the deploy contract and using the function name. And then we will be storing this name inside name, okay? We will do in the same with symbol using the symbol function and with owner using the owner function. Again, the important part here is that you're using the interface with a single argument that is automatically created. When you say that this is an interface, you automatically create an argument that is called contract address, where you have to input the address of the deploy contract that contains the functionality. Okay, so the interface doesn't contain what the functions are doing, it is just declaring the functions that we'll be using, but not the functionality, not the actual inner workings of the functions. These inner workings, you will find them in the actual contract. Okay, so we are getting here the name, the symbol, and the owner, and then we are doing a couple of asserts. And here comes the first testing best practice that I want to tell you. Actually, the first one is to deploy at the beginning of your contract. The second one is here that we are making some assertions, but as you can see, they look different from the ones that we're used to. So you remember that assert actually can do two things. If there's, for example, in this case, if we don't have a variable called name, if the variable called name is empty, it will create it and store it and store inside it what name has. So for example, in this case, if we have 1, then if the variable name is actually not created, then it will create it automatically and it will store the value 1 inside it, okay? In case this name variable is created, this name expression is created, then it will assert in the Python way, see if this variable is storing a 1 or not. In case it doesn't have a 1, for example, it has a 2, then it will give you an error, okay? If it has a 1 indeed, then it will pass, no problem, the assertion will pass. So this particularity that we have in Cairo allow us to test not on a proper way. If, for example, we have the name variable here, and what happens if this call to the name function didn't work and it didn't store anything inside name. So name is still empty, and we add here hola, okay? Of course, this will be a mistake because we don't have strings in Cairo, but this hola will be assigned to name, okay? Because name is empty. So that's not what we want, because then it will be able to pass the test, okay? So that's not a good practice. So what we're doing here is that we are creating first the constant. For example, again, using the hola example, we have hola before name. You can see that. So that means that assert me, please, that name, the value inside name, has actually the same value of this constant. So it's the reverse order, but it works, and it's a better practice in case actually name is empty, okay? So again, we're using name here, and the name was declared above here as a constant, okay? So name is already a constant, and we are reviewing that what comes inside the variable name is actually what the constant is telling us, okay? So this is like a reverse way of asserting, and I find it very useful. So in this case, we're asserting that the name, symbol, and owner are the actual ones that we deployed, with which we deployed the contract when we deployed above using the the setup hook. As you can see here in the arguments to the constructor, I include the name, symbol, and owner. So we are just reviewing that these indeed are okay. Perfect. Now, this is the first test, and let's go back to our contracts in the testnet. As we can see, Arjan is telling us that we were able to declare this animal. So that's great, amazing. And now let's go and read the characteristics of this animal. So this animal has the token ID 1 because it was the first one that we minted. And let's go and retrieve the characteristics in the format of text of this animal. Let's see, something happened here. Let's see what happened. It wasn't text, it was decimal. So in the, yeah, of course, because they were numbers. Okay, so we have sex1, lex1, and weeks1. Just as we said before, perfect, no problem. So animal characteristics, when you input a token ID, you are able to retrieve the characteristics of this animal. Excellent. Also, we have this get last token ID. I'm showing this because we'll be testing them next. Okay, so get last token ID simply tells us the token ID of the last minted animal. So in this case, let's go and query for it. It's telling us the last token ID that was minted is the number 1 because we only have 1. For example, if we were asking for the characteristics of the token of the animal in token 2, we won't be receiving anything, only 0, 0, 0, because these haven't been minted yet. But we have minted the number 1, which has sex1, lex1, and wings1. Excellent. Just for the sake of another example, we'll be declaring a second animal. Instead of being 1, 1, 1, it will have 2 sex, 2 legs, 2 wings. Okay. Sex 2. Okay, and let's go with transact. And again, we'll be writing something on the state of the blockchain, so it will take us a little bit time, a couple minutes, again 3 to 5 minutes for it to work. So let's wait for it. But now we can see that we have other relevant functions such as get animal characteristics and get last token ID. We'll be testing them right now. So let's go to the next test. This test is testing the declare part of the animals, so the minting part of the animals. This one is a little bit stronger, a little bit harder, and is also very interesting, a very interesting test. So what we're doing here is creating a couple temporal variables, again, in order to store the address. Oh, don't mind this one. We won't be using it. And yes, we have first the variable, the temporal variable, will we be storing the address of our contract, of our deployed contract, the one we deploy above at the beginning of our contract. And then we'll be using this interesting cheat code. It's called mock call. Let's explore it a little bit. But this mock call, let's go a little bit to the slides. And this mock call will allow us to simulate a call. Inside the mock call, we will add the first argument is the contract address. Then the contract address of the contract that from which we want to simulate a call. For example, in this case, in the example below, you can see that we are adding the external contract address, which is just again is an example. It's not a real address. The address is 123. This is the beauty of not having to interact with an actual network like a testnet, but we're actually using and deploying locally using Protostar, so we can use mock address, in this case 123, and we are mocking the call. We're mocking the function. So let's go. Okay. As a second argument, if we're using a function name, This is the name of the function from this address that we are mocking. And finally, we will have as a final and third argument the return data. Inside here is in the format of a list, most likely, or a dictionary from Python. You will have the actual return value that you are mocking. Okay. So if we go to the example below, we can see that we are actually, let's go back to our code. And this is the actual example that I was showing before in the slide. And as you can see, I'm creating a mock contract address, as you saw before. And from this, we are using the function called assign lex number, and we are telling it that the return variable, the mock return variable, because we're actually not making a call, it's 10. Okay, so what is this? What contract are we using? What is this address regarding to? It is actually mentioning the interface of the evaluator that I created before. So if we go above in our code, we can see that we create an interface inside our code here, and it's called interface evaluator Evaluator. It has as sake of an example, it only has a function. It's called assign lex number. This receives a player address and returns the legs. So if you tell him, hey, I am player number 3, tell me the number of legs that corresponds to me. But as you can see, we don't have the actual code for this evaluator contract. We don't have it, and I don't care. I'm just mocking a code to it. I'm just mocking what will happen. I know that this function works, that this contract evaluator works. I'm just mocking a return value from when I'm calling this function called assign lex number. Okay, I don't have, again, I repeat that I don't have the actual code of the evaluator contract. Okay, I just know that there's a function called assign lex number that when you input it with the player address, it will return the number of legs. Okay, so again, coming back to our test, we're mocking a call to this address. Actually, I don't even deploy this address. As you can see, I didn't even deploy it. It's just, I'm just mocking this call. I didn't deploy it because I don't have the actual code of the contract. Okay, so this mock call is again calling the assign lex number function from this address, and it will be returning me with a 10. It could be a 9, it could be an 11, whatever, doesn't matter. It's just a mock call. And then using the interface evaluator and the function assign lex numbers, as we said before, then we will provide it with the contract address that again is a mock contract address. We're deploying everything locally, so we don't have a problem with that. And we're telling it that the player address, that's the argument that this function assign lex number was asking for us, is called owner. This will have, and imagine that it has a hex value with an address. So again, we're mocking, and this is not real. Okay, we are just deploying locally. Okay, then the value that we retrieve is going to be stored inside NLX, and we're telling a stop the mock. Okay, then we'll be asserting that indeed 10, the constant, is equal to the number of legs. As you saw before, we said that it should return 10. Okay, so it should pass this small test. So right now we're using this very common cheat code that is called mock call. Excellent. Now let's go to the next part. Here we're retrieving we're retrieving from context. You remember that context is where we are storing everything that we deploy or declare at the beginning of the contract using the setup hook. So here we store the address of the ERC721, and now we're storing it here and bringing it to our contract, to our test. Now let's go to what I think is the most usable and the most beautiful cheat code that we have, the star prank cheat codes. Coming back to our slides, simply what we have with the star prank is that we are simulating, we are cheating, we are pranking a certain contract, telling them, hey, I am the owner, okay, or somebody is the owner, okay, not precisely. In this case, we'll be using it with I am the owner, even though that, as you can see, we don't use a wallet here. And actually, Protostar currently doesn't support for you to be able to sign transactions. No, but it will be soon able to do that. Don't worry. Protostar is in the is being created right now, and it's working. The team's working very hard, and actually they are very responsive on Discord. So I recommend you that if you have any question, go to the documentation. If you don't find there what you need, then you can go to the Discord of Protostar, the StarkNet Discord. Inside you have a Protostar channel. They are very responsive and very nice guys, so no problem with that. But they are currently working on that, and they are working on a lot of very nice and very interesting features. But for the moment being, we can cheat a contract telling them, hey, I am the owner, even though I am not the owner, because this was actually not deployed and sign. Okay, so there's no a clear owner. But I will prank it, telling them that it's me the owner. So the star prank cheat code has two arguments. The first one is the caller address. That's again in this case I will be using it as I am the owner, and yes, I am the owner. And then we'll be telling it, but you can use other address. Okay, you can maybe add that the caller is maybe a third account, and that third account is interacting in certain way with this contract. So I don't know, use it whenever you need to tell it that the caller is somebody else. In this case, I want to tell it the caller is actually the owner. Okay, so why the owner? Because I am minting something, and if you remember the ERC721's code, I will show it in a moment. But you need for the owner original, you need for the owner to call this function to mint. Okay, and then we will have the target contract address. So what is the address that we want to prank? What is the address that we want to cheat? Okay, so coming back to our code, we have this I don't know, not that beautiful maybe code. Let me just erase this for the sake of simplicity right now. And as you can see, we're starting our prank, and here we're finishing our prank. Okay, so this code inside the two hints is the one that's going to be affected by the star prank cheat code. This is beautiful. To be honest, this is beautiful, very nice, and I love it. I love it because yes, it's very easy to use. So in here, we'll be able to, what we are testing right now is the declare animal function from the interface. As you remember before, and we have already called it twice in the testnet, when we call the declare animal, we are telling it that a certain animal has certain sex, certain number of legs, and certain number of wings. If we go back to our block explorer, Voyager, we can see that our transaction already passed, so we declare an animal. So the arguments are sex, legs, and wings. You remember that we already did this twice. And also and this is the most important part, we are telling it that the address that will be the address of the deploy contract that has this function, the declare animal function, is the ERC721 custom address. Okay, and then we are going to be storing, because you didn't see that before, but whenever we declare an animal, it will return us with a token ID for this animal. So this is the animal number 1, number 2, number 3. Okay, so coming back to our code, we'll be storing this animal token inside this first animal token variables. Okay, so let's review what we did here with the star prank, and this is very relevant code. This is a very relevant cheat code and very interesting one. So we're telling this contract called ERC721 custom to the function declare animal that we are the owner and we want to do this. Okay, If we go to our code inside the declare animal function, and of course you will be able to see all this code inside the GitHub repo that I showed before the QR. It's commented. This function particularly is commented, is the most important one. And you can see, you can see that it will only allow us to use this function if we are the actual owners of this contract. Okay, so it's checking if we are the owners. If we didn't use here the star prank cheat code, it won't be able to see that we are the owners, so we won't be able to test the declare animal parts. Okay, this is very interesting. Okay, so for example, in the next part of this automated workshop, the ERC 721, you actually have to create a list of persons, of accounts that are able to mint and declare animals. Okay, so for example, in this case, we could create an Stark prank where the contract address is actually one of these different addresses that are able to mint animals. So we can test that with each of these different addresses, they are able to test. In this case, we don't have this already implemented, so only the owner can declare animals. This is very interesting, right? We can actually, without having to sign the deployment of the contract as me, the owner, you can interact with it. Also in testnet, we can interact with it because it knows that I am the owner, because I tell when I was making the deployment, I tell the contract that I am actually the owner. It is one of the arguments of the constructor. Okay, so right now we have this part, the star prank owner. This is to me the most beautiful test that we have. And then we will be simply testing this deployment. So, okay, so before I erased this part, but what I was doing here is just the same as before. I am minting a second, I'm declaring a second animal. So first animal and then a second animal. The second animal has different number of legs, different number of sex, and different number of wings. Okay, so now I will test it. I won't go into too much detail, but here you can see we have a couple of assertions. These assertions are allowing us to review that indeed our functions are working. For example, we're using the get last token ID. We used it before in testnet. You remember that it retrieve us. It gives us what is the last token ID from the last minted animal. And then we'll be reviewing that it actually works with it is the same token ID as the second minted animal, because we minted two animals, so we want to see that the second animal also corresponds to the last token ID function. Okay, that's all, and then we'll be simply asserting that the animal characteristics work. So we are right now testing the get animal characteristics function. As you remember, I can go here into get animal characteristics function, this one. As you can see, it is giving us the sex, the legs, and the wings, and we have actually used it a couple of times already in the testnet. So we are testing it by assigning to this variable, this local variable, sex, leg, and wings. We are getting the animal characteristics, and we are adding as inputs the contract address, of course, of this deploy contract, and also the token ID. So I am asking here, give me the characteristics of the token ID number of the animal with the token ID number 1, and also give me and ask for this to this address of this deployed contract, the ERC 721 custom. And then we are simply asserting that the numbers are what we expected. Okay, and we're doing also that with the second minted animal that we had, the second declare animal. And that's all. That's practically all. Again, you can go and see the test inside the repo. Now let's see if the actual test work. And whenever you are testing, remember that the tests are stored inside the test folder here. So here I have two tests. I didn't show you the original one, but the original one is simply testing the original ERC721 contract if we deploy it properly. The important part here is the custom end-to-end deployment testing of the ERC721. So whenever we want to test, we can simply go and go into test, build, and I want to only as this is not what I was looking for. I can tell it what test suits we want to test. So in this case, the test. So 21 custom end-to-end Cairo. So right now, what we're doing is testing this suit. So it says collected one suit and two test cases. Now, you will always have a lot of errors in this part. It doesn't matter if you are an expert in Cairo or not. You will have a lot of errors in here. But actually, Cairo and Protostar have very nice. It tells you very nicely when you have a mistake, and it's very easy to debug whenever you have an error. It's very easy. So I'm always having a lot of errors, and I can always go back to my code either in the part of the tests, because you might find an error in the main contract thanks to the test, or maybe you have errors in the test, no problem. So in this case, what you can see is that the test passed, and it tells you that there were two tests, the two different functions that we declared before. There's only a single test suite, and it passed. It only took it 15 seconds for finish the test part. And yes, that is practically all. We could, if for example, we want to test everything, I can only say that I want to test everything. And now it will be testing two suits, the original one and the custom one. But it will tell you, it will take it, I don't know, like 20 seconds. But in the meantime, let's go back. Let's go back to our already past. As you can see, it's telling us that it was a success. Again, it is very likely that you will have mistakes, and it's okay. It's very easy to debug thanks to Cairo and thanks to Protostar, so no problem with that. So just to finish, let's talk a little bit more about what is next in the ecosystem. So I will stop sharing screen for a moment and go back and share again. Let me just a second share screen. This sharing screen part is kind of annoying. Okay, so we review some of the most important cheat codes. And finally, let's go to what is next in the Protostar ecosystem. This is the migrations part. Now, the migrations part is inspired by Truffle. Truffle, to the best of my knowledge, was the first one to create this part of the migrations. And here you can deploy, and you can actually not only prank, actually not prank it, but you can deploy and manage contracts in a network. This could be the DevNet, this could be the testnet, or the mainnet. Okay. However, there's a warning in the documentation that this is actively being developed. And I talk a little bit with the Protostar team, and they are indeed developing this part of the migration. So it's not actively right now, but we'll be having it very soon. But this is the next part of it. We'll be able to make some interesting calls to the actual network. Currently, whenever we want to deploy, for example, in a testnet or in the devnet, and we want to interact with these contracts, we have to actually use the command line interface of the testnet or the devnet. In the case of the testnet, we can use the StarkNet original command line interface, which is also very simple to use. And in the case of the devnet, we can use the Sharp Labs command line interface for the devnet, which is very similar again to the StarkNet interface, command line interface. But we'll be able to do this in the future using only a Protostar. So this is a nice feature. I'm eager to try it. So thank you very much. If you have any questions, please add it to the text wherever you are. No problem, and we can solve them. And thank you very much for it. I want to apologize for for the problems at the beginning. My StreamYard has its own it's its own framework, and you have to to learn how to use it properly. So again, an apology for that. It won't happen again. So coming back, while you input your questions, while you write your questions, remember here you can have the link to the GitHub account, to the GitHub repo where all this is made. You can find the test, and it's also very useful to see the Stark prank and the prank call, the all these cheat codes in action. So you can see them inside here. And also feel free to review the ERC 721 automated workshop, and also David tutorials in case you need help to solve this workshop. It is very, very nice. And again, thank you very much. And let me see if there's any questions. Seems like we don't have any questions. I will stop sharing. Sorry for that. Okay, seems like we are okay, and there's no questions right now. I'm looking for them. Going into YouTube to see if we have any questions, but it doesn't seem so. Excellent. So thank you very much, and have a nice day wherever you are, and see you soon. Go ahead and test your contracts, because it's very relevant and it's very simple to use thanks to Protostar. So thank you very much, and we'll be seeing us soon.